what we want here is fog, f of g of x. So this says in the function f, you're going to put the function g, and f is x squared plus 2x, so that would be f is x squared plus 2x, and g is x plus 8. So wherever I have an x, I put an x plus 8. And they don't want you to simplify your answer. So your answer would be x plus 8 squared plus 2 times x plus 8. Now, g of f of x, that's golf. It says in the function g, you're going to put the function f of x. Now, g is x plus 8, so it's x plus 8. I don't have room for g. G, or f is x squared plus 2x, so x squared plus 2x. So this turns into x squared plus 2x plus 8. And if you didn't have the parentheses in, it seemed to have taken it as well. Now f of f, that says in the function f, you're going to put the function f. So that is x squared plus 2x. So f itself is x squared plus 2x, x squared plus 2x. They don't want you to simplify it, so this becomes x squared plus 2x squared plus 2 times x squared plus 2x. G of g, now in g, you're going to put himself, so there's x plus 8. So what is g? It's x plus 8. Now, it seemed to have taken this rather nicely, x plus 16. Either one of these answers would have been fine. It would have taken either plus 8 or x plus 16. Seem to be happy with either one. This says, which of the following would be inappropriate to show that these two are inverses of each other? Well, this is the definition of an inverse, so that if you do the function composition, that you end up with x. It says compare a table of values. Well, table of values would work because that would say if x goes to y for the function, that the inverse means that y has to return to x. So if you had the two tables together, you would notice that x and y would be reversed. Compare the graphs. That certainly would work too, because I've got symmetry across the line x equal y. Horizontal line test. In this particular instance, it doesn't matter whether or not it passes the horizontal line test, if you want to show that they're inverses of each other. All the horizontal line test is used to do to show you that it does have an inverse, not that who the inverse is. So that certainly would be this guy. Find the inverse algebraically. Well, that's certainly going to be the case. If this is the function, if you work it algebraically, that would end up being his inverse, so that will work out fine as well. So the answer is the horizontal line test thing. Graph the exponential function 5 equals 3 to the x by plotting points. Since I don't have the plotter that they used, and 3 to the x, and it says identify the y-intercept. The y-intercept is where x equals 0, so that would say that 5 times 3 to the 0 power, that's just 5. So it'd be 0, 5. So that would be a coordinate point. And so he's a basic function, so he'll have a horizontal asymptote at y equals 0 and 0, 5. Now I'm going to pick a coordinate point 1. So I'm just do a little t-bar chart. You only needed a second coordinate point when you used the grapher in Moore. And if x is 1, that's 3, that's 15. So 1 is going to be 15. And negative 1 is going to be 5/3, which is 1 2/3. Or, yes, 1 2/3. So it's 1 2/3. So it's about right there. And then I'll just kind of draw it down. And so that's what it looks like. Describe the long-run end behavior of this guy. Well, we're looking at t. So as t goes to negative infinity, I'd have negative 2 times 1/2 to the negative infinity minus 4. Well, this would be negative 2. What this negative does, it flips that fraction. So this becomes 2 to the infinity minus 4. 2 to the infinity is just infinity. So it's minus 2 times infinity minus 4. 2 times infinity minus 4, that's going to be, subtract 4. That's going to be negative infinity. And if t goes to infinity, that says that I have a minus 2 times 1 over 2 to the infinity minus 4. Minus 2, this is really 1/2 to the infinity goes to 0. Minus 4. So this thing's going to minus 4. Graph the following equation. You must clearly identify at least 2 points. And usually the grapher, that's what you have to do. Domain and range, use interval notation. Now if you take a look at this, this is log base 2. So from a transformation point, he is right, not left. He is right 2 and up 1. So that would be log base 2. So what could I do? Well, domain means that what I'm taking the log has to be positive. So that x minus 2 has to be positive, or x is greater than 2. In interval notation, this would be 2 comma infinity. Range, we'll wait for the graph. An asymptote, well, we know that logarithms have a vertical asymptote. It would be at x equal 2. So now, just like I would with my rational graphs, I'm going to put in my VA at x equal 2. And that means I can only choose coordinate points now that are to the left of 2. So for the purposes of this grapher that we are using, I know that 2 is the VA, and I need a point close to 2, so I'm going to do 2 and 1/2. And then 3, that should be enough since to get a graph up. You only needed 2, so if you put in 2 and 3, you would be fine. Or if you put in 2 and 1/2 and 3, or even we'll go down to 4. So I'm just going to do a calculation. If I'm looking at log base 2 of x minus 2, and x, I'm going to put in 2 1/2. So if x equals 2 1/2, this would be log base 2 of 2 1/2 minus 2 plus 1, which is log base 2 of 1/2 plus 1. Now, what you can look at is change a base formula, or you may have a calculator that does the logarithms. Either way would be fine, and you're going to find that 2 1/2 is going to be 0. And if I do the same thing, this would be log base 2 of 3 minus 1 which is log base 2 of 2, and log base 2 of 2 is 1. And log base 2 of 4 minus 1, which is log base 2 of 3, and log base 2 of 3 is 2. And that can't be right. Let's check this out. Now, what you could do is you could do the change of base formula. That's one of the things you could do. That log base 2 of 1/2 would turn into the log of the base, log of the argument divided by the log of the base plus 1. So that would be the log of the argument, which is 1 divided 2, divided by the log of the base, which is 2, and then we're going to add 1. And that's where the 0 came from. Likewise, this would be the log of 3 divided by the log of 2, add 1. Now I'm going to just bring it back by doing second enter. So it would be delete, delete, the log of 3 divided by the log of 2, add 1 is going to be 2.6. So the VA is here, 2 1/2 is 0, 3 is 1, 4 is 2.6, 2.6, so he's going to come down like this. Which means that his range is all real numbers, so it's minus infinity, infinity. Now on that grapher, you just needed to have 2 coordinate points, and then it automatically placed it in the proper position. So you got it easy. Find the domain of the function. Well, again, this brings down to the idea that the argument has to be positive, which means that x squared minus 49 has to be positive. That goes back to 3.6. So find the x-intercepts. So this is x minus 7, x plus 7. So that x is 7, x is negative 7. Then you move to the number line. Multiplicity 1. If I choose a test point, my x equals 0 as my test. This would be 0 squared minus 49, which is of course negative. Change, positive, change, positive. So my answer is on the outside. So the numbers they want here are -7 and 7.